All right, ladies and gentlemen, boys and girls, children of all ages, we're now looking at graphing trigonometric functions. We might call these are often called sinusoidal functions. They model periodic motion. And if we were to look at these along a coordinate plane, the x-axis or the horizontal axis is going to represent each cycle or a period of the function, and then the height and depth that we might see along the y-axis, positive or negative values of y, half of that between the very maximum and the minimum give us the amplitude. And these type of functions are often used to model things like sound, electromagnetic waves, electricity, things of that nature. But we're going to start off looking at sine and cosine functions, zeroing in specifically on the amplitude and the period. And the period is where does the cycle begin to repeat itself? What's the length where the cycle then begins to, along the horizontal axis, where the function begins to repeat or cycle. Now, for both the sine and the cosine function, if we've got y equals a sine b theta, or we'll go ahead and model a cosine b theta, the coefficient or a in front of the sine or the cosine is going to give us the amplitude. And for both the sine and the cosine function, this b, we can use it to determine the period. And for both the sine and the cosine function, the period is determined by 360 degrees over the absolute value of b. Now, sometimes we'll see this written in radians, 2 pi over absolute value of b. Because think about the unit circle, pretty poor circle. But here we got it along the x and y axis. Here at 90 degrees, that's the same as pi over 2. And then here we got 180 degrees, or just pi. And then we got 270 degrees, or 3 pi over 2. And out here at 360 degrees is also 2 pi. And so a lot of times we're flipping back and forth between degrees and radians. Most of what we see here in this chapter in the early part is in degrees, but then it does lapse over into radians a little bit later. So remember those relationships. 90 degrees is pi over 2. 180 degrees is the same as pi. 270 degrees is the same as 3 pi over 2. 360 degrees is the same as 2 pi. All right, so having said that, we're asked here to find the amplitude and period of each function. So this first function, we got y equals the cosine of 1/2 of theta. Well, we don't have, our coefficient here really is 1 in front of this cosine. And so we can say that the amplitude is 1. In other words, it's going to go as high as 1 and down below as -1 on the coordinate plane. Now on the period, here's our value of b, 1/2. So let's say we would have 360 divided by 1/2. And I'm just leaving off the absolute value because it's a positive number. And this 360 is the same as, 360 divided by 1/2 is the same as 360 times 2. And 360 times 2 is 720. So the amplitude is 1 and the period is 720. Now let's look at this next one. Here we got y equals 3 times the sine of 5 theta. Well, again, that coefficient defines our amplitude. And so the amplitude is 3. and then the period over what measure does this function begin to repeat itself, would be 360 over 5. And if we do the math on that, let's see, 3 is going into 36 7 times, that's 35, 1, 10, 5 goes into 10 2 times, it's going to be 72 degrees. Now, this particular exercise, which came from page 837 in the textbook, doesn't ask us to get into the graphing, although the next example does. But I went ahead and just pulled some screenshots of some things with the graph so that we can look at a couple of things that are kind of particular to graphing sinusoidal functions. So I'm going to move over here to the next slide. And one of the first things that we got to really think about, one, we want to go into the mode, which is, the mode key is up by the second button underneath the window button. And you want to make sure that you're in radians. Anytime we're dealing with trig functions or just trigonometry in general, we're always kind of flipping back and forth often between radians and degrees. And so first thing, you want to determine, okay, do I want to be in radian mode or degree mode? And then make those adjustments depending on what you do. And then on my window settings, and I think this one, sometimes a lot of times on the X and the max, you got to play with it a little bit. Here I've got it set, I think, at -6 and 12. But the key thing I want to point out is this number right here, this Y scale. Now that's a big number, but that is simply pi over 2. In fact, when I went down to the Y scale, and that's going to give each little tick mark on that along the x-axis is actually going to equal pi over 2 or 90 degrees. And on the y minimum and maximum, a lot of what will depend upon that is what is that amplitude. And here I just set it for -5 and 5. A lot of times I don't even need a range that large. I could narrow it down to -3 and 3 or -2 and 2. Now I'm going to move here to another slide, and I think I've pulled some screenshots of the graphs of the functions that we just looked at and determined the amplitude and the period. So this one on the left here, this is y equals cosine 1/2 theta. And on the next video we do, we'll go in and we'll actually graph some. I don't use theta in the y equals function. I use x, but because I don't have a theta. Well, I guess I do, but x seems to work pretty well. Now let's look at this. 1, my amplitude is 1, and I can see that it goes. Here's the high point at 1, and then here it goes down as low as -1. And of course that's half of that amount, so my amplitude is 1, as we know. And then each one of these tick marks is 90 degrees. And so my cycle goes from here out to here, and you can't quite see, but you can see that it's headed in that direction. So if I look at that, now we figured the period was 720. Well, that's 90, that's 180. That's 270, 360, 450, 540, 630, and right there is 720. And we see that period or that cycle in this cosine 1/2 theta is 720. Now over here on the right, I also went in and graphed the other function where I got y equals 3 sine 5 theta. And again, I can see if I look at my y-axis, 1, 2, 3, well, there's my high point at 3, 1, -1, -2, -3. I got a trough there at -3. The difference between 3 and -3, half that absolute value of that is then 6, which is 3. My amplitude's 3. And we figured that our period was 72 degrees. So let's look. Here we start at 0. And right. And when we get to this x-intercept, see, we're on the decline. So that's not completing that period. But right here, we're headed back on the upswing. Well, that tick mark right there, and I did use in my window settings here, I might tell you, I used x min of -1 and x max of 6 rather than what I did on this one. And that's where you kind of got to get a little feel, kind of, okay, how do I want to view this? And you'll get some experience with that as you do it. And so I can see that my period is not quite at 90. I figured manually it was going to be 72, and that looks about right as to where it would be for that period. All right. Sinusoidal functions, sine and cosine functions.